of data breaches. I like to go up to Data Loss DB and just have a look at kind of what's going on out there. There's so many data breaches that the media hardly reports on it anymore. But when I count records stolen in 2011 from the breaches on Data Loss DB, only counting breaches that were over 1 million records, there's just way too many under 1 million to even bother to count. I got to 330 million records, which seems to me to be an awful lot of data. And then I read the Verizon Data Breach Investigation Report. Verizon does a lot of forensic investigations, and they and a number of their competitors out there publish data breach investigation reports where they talk about the ways and means of the attackers that they investigated. And Verizon year over year tells us that most of the data, usually over 90% of the records that get stolen out of databases, which really isn't a surprise. Most of the data that we store gets stored in databases, so you'd think that if data was to be stolen, that's where it will be stolen from. A clear trend that I've seen is that organizations don't tend to take database security very seriously. And I think that's one of the root causes of the amount of data that we see leaking out of databases on a year-over-year basis. Now, I talk to a lot of folks who start the conversation with me about database security with, well, I've got a firewall, I've got a network security team. Why do I need to worry about my database beyond that? And, you know, there's a lot of talk about the perimeter being Swiss cheese and passé and whatnot, but I think this is a much more interesting piece of data here. This comes from Brian Krebs' security blog just a couple of weeks ago, where he wrote about online services that sell access to compromised Windows hosts using remote desktop on Fortune 500 networks. And this really blew my mind, because for about $5, you can buy complete access to a Windows host on the inside of big money company network, Fortune 500 company, and then do what you want with those Windows hosts. Now, it's just kind of set up for bot farmers who are looking to add more machines to their botnets to be able to do that for a couple of dollars each from fairly trusted sources. But I could think of a lot more nefarious things to do if I've got a machine on the inside of the network and I can, for example, talk to the databases on that network. So think of this $4, $4.50, $5 service as we walk through our attack scenarios today. And then I read the news a bit, and I wonder if anybody's surprised when they read these headlines: cyber gangs seek bot masters to wave massive wave of Trojan attacks. Hackers publish personal records from 53 different universities online. Even IEEE has data breach issues. Global Payments, which had a big breach. First it was going to cost them $85 million, then the damage wasn't quite done, and it was going to be later in October they reported a lot more. And all the while we've got surveys telling us that business executives remain confident on security, while clearly all is not well. You know, I read these headlines, and it's just sort of what I expect to read at this point. It's what I've been seeing for the last 10 years out there. Let's talk about why. And if you're familiar with OWASP, the Open Web Application Security Project, they've had an awesome tradition going for a long time now of publishing a top 10 web application security vulnerabilities. I asked our team, Team Shatter, we're the database research team, to go out and tip the cap to OWASP and build our own top 10 for database vulnerabilities. So I'm going to run you through the top 10, and then let's take a look at some of these top 10 and hack some databases using some of these vulnerabilities. So we'll get started with default accounts and weak passwords. All the databases ship with some default accounts. Those default accounts have default passwords, which are easy to find on the internet. Most applications that you install on your database bring additional default accounts with default passwords that are well documented. Of course, users need access to databases as well. If they put weak passwords into the database, it's just an easy way in. Weak passwords in a database are just like weak passwords in the other system. They're a bad idea. Number 2 is SQL injection in the database. Now, we hear about SQL injection in the security news all the time, and most folks are talking about SQL injection at the web application level. I'm talking about SQL injection right inside the database. Databases ship with functions and stored procedures, some built-in functionality. Those functions take arguments from the user. If I can stuff SQL into those arguments, for example, I can get SQL to run on the database and maybe get access to data that I shouldn't have access to. We're going to hack some SQL injection vulnerabilities today. Number 3 is excessive user and group privileges. This is probably the most obvious. Assign people access to data that you don't want them to have access to, and they can access data that you don't want them to access. We see it happen all the time. Folks tend to turn a blind eye or don't tend to do the detailed work that's required when they're provisioning user access to their databases and the data inside. Number 4 is unnecessary features. So common to talk about surface area in the security world, and it's so important. The more surface area you've got, the more code you've got running in your environment, the more bugs you've got as a result of more code, and the more bugs, the more security vulnerabilities, the more potential risk. So the last thing you want to have is features and software that you're not using up and running and enabled in your systems. It gives the attackers an opportunity to use that stuff against you. So we see that with databases all the time. The vendors ship lots of features by default. The databases are configured for convenience, and you've really got to turn off features that you're not using in order to limit potential risk exposure down the road. Number 5 is broken configuration management. Databases are super complicated applications. So many different configuration settings and parameters, so many opportunities to make a mistake. And again, the database out of the box is configured for convenience. A lot of the security features aren't turned on or aren't turned up to the level that you really want to run them at production. You've got to make these changes on your own, and you've got to know exactly what changes to make. Clearly, security features don't work if you've turned them off or aren't using them. Number 6 is buffer overflows. Number 7, privilege escalation. Number 8, denial of service attacks. We hear about these kind of vulnerabilities in all sorts of systems and have been for a long time. They exist in databases as well. Number 9, unpatched databases. Organizations really struggle to patch databases. It's much more difficult to patch a database than it is to patch a piece of networking equipment or to patch a server OS. Databases are considered to be very delicate, particularly in the balance that they strike working together with an application. So it's uncommon to see databases patched any more often than once every 6 months or a year, which is a problem when database vendors are releasing patches 4, 5, 6 times a year to deal with security vulnerabilities. And then finally, number 10, unencrypted data, both at rest, sitting in the database, as well as in motion, flowing across the network. We see very few folks using database encryption, and I think there's some good reasons for that. But turning on encryption on the network is a simple thing to do that folks don't tend to do that does make it easy for somebody who can access the network to potentially steal a bunch of sensitive data. So let's dig into each of these categories, and let's throw up some exploits, and I'll show you how hackers take advantage of these vulnerabilities and misconfigurations in databases. So I mentioned that databases have default accounts and they have default passwords. So many opportunities for somebody to break in using one of those default accounts and passwords. Just got to make sure that you're eliminating all the default accounts in your database systems and not just locking those accounts. You don't have to delete the logins, but at least go ahead and change the passwords. It's also important to monitor login activity so that you don't get caught with somebody guessing passwords all day trying to break into your database. Some examples of some of the default accounts that the database is shipped with. Oracle's got the most powerful account in the database. It's called sys. The password for sys is my favorite default password, change on install. When you install Oracle and you fire it up for the first time, you've got to log in as sys, and you've got to type that change on install password. I can't tell you how many folks type that password and then don't actually change it, and how many Oracle databases I've gone to in production that I could log in with sys and the password change on install. That's not a good thing. The account Scott, there was a developer at Oracle named David Scott. He had a cat named Tiger. It's a demo account in the Oracle database. It's a very low-privileged account that a lot of people forget about and don't delete. If you combine a low-privileged sort of guest account in your database with some of the vulnerabilities that I'm going to show you today, you quickly take control over a database server. MySQL's got a root account, the most powerful account in the database. It's got a blank password by default. SQL Server and Sybase both have an SA or sysadmin account. Both has a blank password by default. Now with SQL Server and the installer, you've actually got to check a special box if you want to keep the blank password on the SA account. I'll tell you, I've been developing software for a long time, and one thing I've learned is that when you put features in your software, people will use those features. Putting a checkbox in the installer that lets you leave the sysadmin password blank is something that some people will check. And unfortunately, we still read about attacks that take advantage of SQL Server with blank SA passwords. DB2 doesn't even have an internal authentication system, but it still manages to bring new accounts with new default and weak passwords into the environment. It typically relies on operating system authentication, and it'll create new operating system accounts with default passwords to allow access to the database. Well, one other example of accounts that will get you are accounts with the username and password set the same. A lot of the default accounts in Oracle databases have a username and password with the same combination. One of them is DBSNMP. I see DBSNMP turned on almost everywhere. It's used to manage the Oracle Intelligent Agent, which lets you hook Oracle up to a central management console. Anybody know what DBSNMP stands for? Oh, it's quiet in the room. I think it stands for Database Security, Not My Problem. Anyway, let's move on. Let's attack a database. Let's take advantage of some default accounts in the database and attack them using a vulnerability that lets us guess passwords. So here we're going to attack Oracle 11g Release 2. This is the latest version of Oracle, probably the most widely used database on the planet. I can do this without a login to the database. I just need to be on the network. So anybody on the network can run this attack. And what we're going to do as a result of the attack is we're going to log into the database. We're going to get the password for any user account we want. We know SYS is always there in Oracle and is the most powerful account, so we're going to go and log in as SYS. We're going to do this by exploiting the stealth password cracking vulnerability, which was reported by Esteban Martinez-Fallo of AppSec Inc.'s team Shatter. Oracle just patched this in their October 2012 CPU. So here's my screen, and there's two elements here. In the background, I'm running Wireshark. Wireshark's a packet sniffer. It listens to network communication and displays the raw contents of those network packets on the screen for me. In the foreground, I've got a Windows command prompt open, and in that command prompt, you can see here that I'm running a command line tool called SQL+. That's Oracle's ad hoc query tool. And I'm going to try to log into the database. I'm going to try to log into the database as SYS. Now, I have no idea what SYS's password is. I need Oracle to just respond to this login with some information. And this information I'm going to be able to use to my advantage. I'm going to be able to use it to figure out SYS's password. So one attempt to log into the database here, I get an error, invalid username and password, login denied, just what you'd expect from a system when you passed it the wrong login credentials. Now, if I take a look at the data collected by Wireshark, I have some interesting data that came back from Oracle. I have these two values that I'm showing you here. One of them is called auth sesh key, and one of them is called auth VFR data. In Oracle 11, Oracle introduced a new login protocol. And they introduced that new login protocol to make their passwords case sensitive and to make some other security improvements with logging into the database. Oops. With that new login protocol, they changed the way the logins work. And the logins started to work with this new exchange of information. And these values that you can see here captured by Wireshark are part of that login protocol. Because of a mistake made or an oversight made when that protocol was designed, these values disclose enough information to the client to be able to perform a password guessing attack offline. So I can use this data and understanding of how Oracle login works to work backwards effectively and figure out any user's password. So what we did was we wrote a simple script that will run through every combination of typable characters, a simple brute force script and use this data collected by Wireshark to verify whether we've guessed the user's password correctly. This allows us to guess passwords all day, all night, millions and billions of attempts without logging anything on the database server, without creating any login trail or audit trace or any other evidence. So we're simply going to type in those characters that we saw on Wireshark, the auth sesh key and the auth VFR data, into this script. The script is then going to run, and it's going to run through, again, all combinations of typable characters. And you can see this at the bottom of the screen is telling me it's guessed about 9 million passwords, and it's running about 1.8 million passwords per second. And eventually, it finds a match, and it finds the password. In this case, it found a match with the password EKO12. So that's all there is to it. We've now got the user sys's password, so we can go back to the database, use SQL Plus to log in again, but this time, instead of the no pass guessing the password, we're going to actually put the right password in. The database is happy to have us, no errors, and if we ask it which user we're running as, we see that the user is sys, and again, sys is the root account in Oracle. It owns all the database and all the data inside of it. With this vulnerability, it's fairly easy for anyone to break in and take over any Oracle 11 database in your environment that you haven't patched yet. So let's move on to SQL injection. Same idea as in a web application, but now we're talking about at the database level, inside the functions and stored procedures in the database. Now because of that, we can't just change the code to fix it. We can't just do better input validation. We've got to patch the database because we're talking about vendor ship code. And if you're on that typical 6 to 9 to 12-month patch window, you may have exposure for some time. So let's look at a SQL injection vulnerability here. This time, our target's going to be Microsoft SQL Server 2008. I need to log into the database that's got the create database privilege in order to run this attack. The outcome here is going to be to take full control of the SQL Server. I'm going to become the SA user. And I'm going to do this by exploiting SQL injection to perform a privilege escalation attack using the built-in restore function in SQL Server. This vulnerability was reported by Martin Rachmanov of AppSec Team Shatter. And Microsoft doesn't consider this to be a vulnerability because it's a lateral privilege escalation, and so they have no plans to patch it. Now, what do I mean by lateral privilege escalation, and what's this create database? So create database is a privilege that allows me to create a new database in an existing database server. The typical way Microsoft SQL Server is deployed is you stand up one really big, powerful server, and you load up a bunch of different applications onto it as individual databases. And then you only have one database server license to pay for, but you have lots of separate databases, separate apps that are sharing that one database server. Microsoft built some fantastic segregation of duties features so you could have different administrators for those different apps that can't see and touch each other's data. So a user in SQL Server with create database can create their own database to effectively host their own application, but they can't see or touch anybody else's data, and they can't manage the SQL Server itself. So because I've got create database, I'm some level of administrator in the database in Microsoft terms, and I'm going to escalate to full-blown server administrator, but that's still administrator to administrator escalation. That's what they mean by lateral escalation. Now, how do you get yourself create database privilege? It's usually pretty easy. You just request it. I've got to install a new application. That application requires a SQL Server database to store its data. We're just testing proof of concept style testing this application, and the application needs to create its own database. So please give me a database account, give me create database privilege temporarily. I'll run my installer, and then you can take that create database privilege away. Folks are easy to give that up because there's very little risk associated with it. So let's log into the database. We're going to log in as an attacker that's got the create database privilege. I'm going to use OSQL, which is Microsoft's command line ad hoc query tool. I'm logging into the database here. You can see the server IP address and name, and you can see that I'm logging into the database with a user named Hacker Harry, and the password is Harry$123. Now, when I log into the database, I can run a query to get SQL Server to tell me what version it is. You can see here I'm running SQL Server version 2008. If I try to access sensitive data in the database, so give me the usernames and passwords that are stored in the database syslogins table. What I get back are two users, SA, which is the built-in system administrator, and my own user, Hacker Harry, and it says both passwords are null. Now you saw me just log into the database with Hacker Harry and the password Harry $123, so you know my password's not null. The database is just refusing to show me anything sensitive that I shouldn't be able to know on my own. If I try to give myself the system administrator role in SQL Server by running exec sp add server role member, Hacker Harry, give Hacker Harry the sysadmin role, I get an error. Access denied. You don't have the permission to perform this action. That's good. And if I try to get access to somebody else's data by opening up another database, in this case a database called AdventureWorks, I get an error again saying Hacker Harry is not able to access the database called AdventureWorks. You don't have privileges. So I've got a low privileged user. The privilege I do have is to create a database. So let's go ahead and do that. So I'm going to create a new database, and the syntax here is create database and then the database name. Now once I've created a database, I can back that database up. So the syntax this time is backup database, the database name, and then where you want the backup to go. Now for this attack to work, I need to actually get my hands on the raw backup file. But SQL Server is happy to send the backup to me across the network. It supports a UNC path. So you can see I've got backup database, and then it says to disk, and I've got a UNC path pointing over to my attacker machine where I'm going to collect this backup file. Database processes that for me. There's no data in the database, so it takes less than a second. Now that I've got my backup file, I can drop the database, just delete the database that I've created. Before I move on, I want you to take a look at the name of the database I just created. It's called single quote, comma, 0, comma, 0, comma, 0, exec sp add server role member, give Hacker Harry the sysadmin role. This, my friends, is what we call SQL injection. So let's make it run. I'm going to go ahead and open that backup file that we just created. So I'm going to use just a free hex editor called HXD that I downloaded. Inside the backup file, I need to search around and find the database name. So you can see it right here, single quote, comma, 0, exec sp add server role member, so on and so forth. Now once I find this database name, I need to look for a special character in the file. And it's this character right here, the number 27. I've got to find the byte 27, and then I've got to change this byte from a 27 to a 7. Now by doing this, I'm going to trick SQL Server into running the database name as SQL when I restore the database. So I'll just save this off, and now back to SQL Server. I'm going to restore the database. I can restore it again across a UNC path, so it's going to come again from the same machine across the network, this file that I just changed. Very quick to restore the database if empty. And now that the database has been restored, if I go back and try to access those usernames and passwords again, things are really different. Now I can see a lot more usernames, and I can see password hashes. You see those smiley faces and question marks there? That's ASCII trying to represent binary data, so it looks a mess. But what's there are the raw password hashes that I'm looking for. The ones that are still null are null because they're operating system authenticated accounts, and the database isn't storing the password hash. If I try to give myself the sysadmin role, no problem. I've already got the sysadmin role. And so if I try to use somebody else's database, once again, no problem. I can get access to any database on the entire SQL Server. So if you're out there and you're running Microsoft SQL Server with one of these big servers that's hosting more than one or two apps where you're trying to make sure that one admin can't access another admin's data, this is a vulnerability that exists in your SQL servers that Microsoft has decided not to address. I tried hard to convince them to fix it. They're not listening to me. Let's move on. Number 3, excessive user and group privileges. So it's very easy for me to sit here in my office chair and talk to you on the phone and tell you that you should implement the theory of least privilege, and you should make sure that every user has only the privileges they need to do their jobs. It's so easy to say it, but I understand how ridiculous and impossible it is to actually think of implementing that in, particularly in an enterprise that's got some legacy out there. Entitlements are pretty difficult to manage, but they're not impossible, at least to start to get your arms around, particularly if you've got some tools to help you. So understanding what a user actually can access and getting a map of who the effective privileged users are in your environment is pretty darn important. If you don't know who has access to what, then you may have given people access to things that you really don't want them to have access to, and that can prove to be dangerous. Now, database access controls are complicated, so it's not easy just to look at the database and find out who has access to what. Databases use roles. Roles can be granted privileges, but roles can also be granted other roles. So to find out something simple like who has execute rights on sys dbmshs, to know that gtrog here has those rights, you have to figure out that he gets them because he's a member of a role, that's 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 a member of a role. It can get pretty crazy with the way that roles are members of other roles and the way privileges are handed out in a database, just figuring out who has access to what. Unnecessary features. So you really want to minimize the attack surface and limit what attackers can use against you. Databases have a lot of powerful features. They're fantastic if you've got something specific to do with them. They're also terrific if you're an attacker and you find that you can take advantage of them. So most databases are shipping with a Java engine these days. We're seeing a lot of vulnerabilities with those Java implementations. If you're not running Java on your database, there's just no reason in the universe to have Java installed on your database. It's there by default to be convenient for you. Sometimes it's turned off by default. You're just going to make sure if you're not using it, that you're not using it. Databases also ship with tools to let you access the operating system through the database. So you read about SQL Server and the XP command shell function giving you access to Windows in security stories all the time about how attackers managed to use SQL injection to talk to SQL Server, and then they owned the network because it ran as administrator, and they could just use XP command shell to get to the operating system. If you're not actually taking advantage of a function like that, you want to delete it from the database so that it's not there for an attacker to use. So let's exploit unnecessary features. Let's attack IBM DB2. We're going to attack DB2 on Windows here. We need to be able to log into the database only. No additional privileges are required. So here's where one of those demo accounts or guest accounts can really bite you. We're going to be able to take full control of the database as well as the server that it runs on. We're going to become an operating system administrator here. And we're going to do this by loading and running arbitrary code using the built-in Java system in DB2. This vulnerability was reported by Martin Rachmanov of AppSec Inc.'s team Shatter, and IBM patched this in August. So what this vulnerability lets me do is load and run Java code, load Java code onto the database server, and if I can figure out how to run that Java code. So basically we can load malware on the database and run malware. So let's write malware. Our malware is going to be really simple. It's all on the screen right now. There's really two lines of code here. Both of them call the function runtime.getRuntime.exec, which runs Windows commands. The first Windows command I'm going to run is netuser myuser/add, which is going to create a new Windows user named myuser. The next command I'm going to run is netlocalgroup administrators myuser/add, which is going to add that user, myuser, that we just created to the built-in Windows administrator group. So that's my malware. Of course, my malware could do anything. It could load and run Zeus or other Trojans, rats, anything you want to load up onto the box can be done here. Any commands you want to run, of course. We're going to own the server and run our own code. Now I need to compile up my malware, so I'm just going to run the regular old Java compiler, and I'm going to end up with the jar file mycode.jar. One thing to note about mycode.jar, just look at the size, about 1,650 kilobytes. Just a little tiny file. Now the next step is to package and deliver my malware to the database. So here's where we're going to take advantage of the vulnerability. So I need a little more code. Again, this is Java code. It's real simple. Let's walk through it. Here's a string. It's called URL. This is how we're going to log into the database using this string. So we're going to make a JDBC or Java connection to the database. It's a DB2 system. You can see the IP address and the port number it's running on, and the database name is sample. Very simple. Now, a couple of paths to point out. We need to tell the database where to stick the Java, our malware, where to load it. So what you see there on the remote jar path line is a relative path from the database's perspective to the location and the file name that we wanted to plug our malware in. So we're going to be writing this into, you can see the IBM SQL Live Java directory, into a file called DB2 DBGM, which is actually a jar file that already exists on DB2. It's the DB2 Debug Manager jar file. We're going to actually try to overwrite the built-in DB2 debugger with our malware. The other jar file you can see points to mycode.jar. Here we use some of the built-in functionality in Java to get a new connection to the database. So we call this getConnection function. We tell it the database name using that URL. We're going to log into the database as a user named Joe, and you can see his password there. Joe's a very low-privileged user. And now we're going to load up our malware using the vulnerable function. So here we're going to call SQLj.db2 install jar. That's the vulnerable function. That's the function that lets any user on a DB2 system load any jar file they want on the database. To do that, it takes a couple parameters. One of the parameters is the Java you want to load, and you pass it in a binary object. So we need to put together that binary object using that function setBinaryStream. Then we need to tell again the database where to load it. So we're going to pass it the remote jar path, and then we'll execute this statement. Now that's going to load the code up onto the database server. The last step is to run it. Now the reason we chose to overwrite the debugger was because anybody in DB2 can run the debugger. Public has rights to run the debugger. And you do that by call sysproc.dbg, the debug run session manager. So we're just going to call this the debugger. That's going to run the jar file that we just overwrote, which is going to cause our malware to execute. So all we have to do here is compile and run the Java that I just showed you. It runs. And now if we go over to the database server, you can look, here's a before and after of the user list. Notice in the after, we've got a new user added to the list, my user. And if we query my user's privileges using the command netuser my user, and you look at the local group memberships, you can see that we've got administrative access on this box. So simple and easy, we went from low-privileged database user to full-blown administrator on the operating system. We can access the database. We own the OS. We can move laterally from here to other servers in the environment. Microsoft says this isn't a vulnerability. I disagree. I think it is. If you're concerned about it, call Microsoft and tell them to fix it. Let's move on. Number 5, broken configuration management. So I said databases are complex earlier. I mean, they sure are. There's just an overload of configuration options. So many of them are not set securely out of the box. And you've got a lot of basic stuff that you've got to do just to get the database running and working that you get your hands full with. The security options can really be an afterthought if you think of them at all. And one of the tough things for organizations is that they ask their database teams to build secure databases, but nobody writes down what it means to be a secure database setting by setting. So there's no real target to aim for. And if you don't have a target to aim for, it's really hard to know when you've hit that target. So a lot of folks struggle out there with what should their secure configuration be, and how do they know when they're actually there and when they're not. Here's some examples of configurations on the database that can be a threat. On Oracle, we've got the Oracle Configuration Management that just gives out too much information. In Sybase, you've got an auditing system that can lose audit records if the system's not set up properly, and it's very easy for the system not to be set up properly. SQL Server runs on very well-known default ports, 1433 and 1434. It really advertises itself on the network if you're using those ports. A parameter that really kind of blows my mind is the Trust All Clients configuration parameter on DB2. I said it earlier, I'll say it again. If you put features in your software, some people will definitely use those features. So this feature, Trust All Clients in DB2, basically disables the entire database authorization system. So it says that trust somebody else to authenticate my users and just let everybody in and let them do what they want. So it makes all connection attempts assumed to be trusted. It's like a big knife switch where you turn security off. I can't imagine why they want to offer that. And unfortunately, I know somebody pulled the switch in the wrong direction. It's something to be cognizant of. Moving along, buffer overflows. So with a buffer overflow, I can crash your database very, very simply. Or if I think it through and work hard enough, I can probably load and run arbitrary code on the database server. Now, to be honest with you, there's probably no reason to bother to work hard to load and run arbitrary code with a buffer overflow when I can do it the easy way with some of the Java systems like what I showed you earlier with DB2. That being said, there's still the potential. These buffer overflows are out there, and for somebody to knock down your database is no big deal. And it takes a vendor fix in order for you to close one of the holes that a buffer overflow here brings. So again, you're back to waiting for that next database patch window to get the patches installed and get the vulnerabilities fixed up. Privilege escalation. We go from a low privileged user to DBA or get access to any data or functionality I want. Once again, these tend to be issues in built-in vendor code that you need a patch to fix. So let's escalate our privileges. This time, let's attack Sybase. We're going to attack Sybase 15.5. We need to log into the database, but no more privilege than just the ability to log in. We're going to take full control of the Sybase server. We're going to go from that low privileged user to SA. We're going to do that by exploiting a privilege escalation vulnerability using SQL injection and a built-in function dbcc import metadata, which just happens to be an undocumented function that everybody in the database has irrevocable rights to run. This vulnerability was reported by Martin Rachmanov of AppSec Inc.'s team Shatter, and Sybase put a patch out there for this in September. This time we're going to use the Sybase tools for the database. Sybase just makes some GUI tools here. So we're going to log into the database once again with Hacker Harry. You can see the database IP address and port information. Let's try to read sensitive data from the database. So let's try to read usernames and passwords once again. And when I do that, I get a big fat error message that says, sorry, select permission denied on column password of object sys logins. You don't have privileges to select from the password data. That's what it's telling me here. That's good. Now, what if I try to grant myself the SA role, the sysadmin role? So use this SQL statement, set role SA role to on. And once again, I get this big mean error message here, set role fails. The caller is not granted the specified role. Sorry, you're not allowed to be the SA in this database. Well, that's good too. I'm a low privileged user. I shouldn't be able to be the SA. But of course, it's easy for me to be the SA. So in Sybase, there's a database that's built in called TempDB. It's the temporary database. It's where you create temp tables in Sybase. Temporary tables are very commonly used across all databases for intermediate calculations. They make life a lot easier for applications. In Sybase particularly, we make heavy use of temp tables. The thing about TempDB is that anybody in the database can create a table in TempDB. Even if you haven't granted anybody any kind of create table rights, they can still create table in TempDB. There's nothing you can do about that. So we're going to take advantage of that, and we're going to create a table. The syntax here is create table, and then the table name, and then some information about any columns you want to have. So I've got a table with a big, long table name here, and one column called ID, which is an integer. Once I've created my table, I run the vulnerable function dbcc import metadata, pass it these two parameters, and off it goes. Now when this runs, it's going to look at the table name that I just created, and notice inside that table name is some SQL, grant role, SA role to Hacker Harry. So I'm going to get an error, and this error says something about can't drop a table, but I'm not worried about that. I'm not trying to drop a table. I'm trying to get myself ownership of the database server here. So at the end, it tells me that it's done a few things, and it gives me some execution time, so that's encouraging. When I now go ahead and try to turn on the SA role, so set role, SA role on, remember I got a big mean error when I ran that before. No more error message. And now I see I've got execution time. It's happy. I've become the SA. So if I try to do something like get access to sensitive data, once again, I'll just use usernames and passwords as an example. This query that failed earlier now produces lots and lots and lots of data for me. So there are the usernames and the password hashes that the database stores. So I've got access to everything. It was that simple, just a few commands on Sybase, and I went from public kind of guest user to full ownership of the database server. Now, if you are running Sybase, I got some bad news for you, but I want to let you know that the last urgent notification Sybase put out, which was over the summer, it was in late July, they listed these 12 vulnerabilities that they were patching. And they gave, just this list gives you quite a bit of information about these 12 vulnerabilities. Unfortunately, when we took a look at the patches, only 2 of the vulnerabilities that they attempted to patch were properly fixed, which left 10 vulnerabilities disclosed to the public without any fixes available. Now, I just showed you one of the 2 that was fixed. Well, and Sybase is working on fixing the other vulnerabilities, but some of the other ones are pretty similar, and there's not much of a workaround in place. So if you are running Sybase, you've got to be really vigilant and diligent about the monitoring the use of your databases right now to make sure that nobody's abusing these unpatchable vulnerabilities. And if you want some more information about that, feel free to reach out to us through teamshatter.com or after the webinar, and I'd be happy to chat and give you some more information. Moving along here, number 8 is denial of service. So anybody remember the slammer worm? You realize that was like almost 10 years ago now? The slammer worm took down 75,000 victims in the first 10 minutes alone. I remember the entire Bank of America global ATM system went down, and I remember it well because I was trying to get cash and I could not. Now, Microsoft had patched SQL Server 6 months before the slammer worm hit. But still, the first 10 minutes, 75,000 systems went down. People simply weren't patching their databases 10 years ago, and they're not doing much of a better job today, which may have set up a similar situation if there's another big vulnerability out there that's just waiting to be disclosed. Let's do one more exploit. I can't resist this one. We're going to attack DB297. Anyone on the network can run this attack, so I don't need to log into the database. I just need to be on the same network as the database or be able to communicate across the network with the database server. I'm going to knock the database offline, and I'm going to do it with denial of service exploit here. IBM patched this in 9.7 fixpack 2. So this is a little Python script that contains my exploit. It's very simple. You see the payload is defined there. The payload is what I'm going to send to the database that's going to knock it offline. I'm just going to send the database these 5 bytes, and the database is going to go away. So we define our payload. Then we check and make sure that we got some good arguments on the command line. We're expecting somebody to give us an IP address and a password. We're going to open a socket, make a connection to the IP address and the password that came in on the command line. We're going to send those 5 bytes to the payload, and then we're going to exit. Very simple. So when I run this script with an IP address and a port, it says done. No real work to do here. The database is gone now. And if you look at the event log here on this database server, you can see the monitoring agent for DB2 terminated unexpectedly. It's done this a few times. But the database has crashed. Once the monitoring agent crashes, there's no more database to talk to. So 5 bytes across the network takes down, an industrial-grade DB2 database, which happens to be running your financial trading system in the market that day. This could be a painful 5 bytes. Number 9 is unpatched databases. So I think we've beaten the unpatched databases to death here. The databases are just vulnerable as soon as the patches come out because the information about the vulnerabilities is disclosed. And security researchers will also disclose often full proof of concept exploits the same day as the vendors publish the patches. So the attackers have exploits often in their hands long before there's any chance to patch your databases. And so you've got to think about which databases you're going to patch first and how you're going to get those critical business systems patched in time to make you feel comfortable that somebody isn't going to take advantage of one of these vulnerabilities. Finally, encryption, or lack thereof. Database encryption is not the silver bullet, not by a long shot. It's number 10 on our list because it's a limited protection you're going to get. But there's two kinds of database encryption. There's data at rest, where you encrypt the data inside the database or on the disk. To be honest, there's limited value there. It's interesting, and you could do things like prevent the tape falling off the truck scenario from being a data breach. Maybe more interesting is data in motion. Data is flowing across the network. It's very easy to turn on the network encryption like SSL on your database and have all the database network encryption, network communication be encrypted so they're protected. That usually has no performance impact on anything, no impact on the clients or applications, but it does prevent a network sniffer from stealing your data. I think it's a good idea. I don't see a lot of people doing it, but it's typically free built into the database, so folks ought to take advantage of it. So let's spend the last few minutes here talking about a process to actually go ahead and secure your databases. So we're going to walk through a 5-step process here and what we recommend for doing database security. It starts with inventorying your databases. You need to know what you have in order to protect it. So you've got to be able to locate all the databases on the network and then understand which of those databases are really important. So where are all the databases? Not just the ones that are in active use. Obviously, you know about your mainframes running the core HR applications, and you know about the big Oracle systems that are running your financial reporting. But do you know about every database running in the environment, all the tests, all the dev, all the old apps that you forgot about? You really need to know about everything. And you need a process to remove unauthorized systems. You also want to track when databases first became known so that you can make sure they get secured in a timely manner. It's not good enough to know you've got a database and then not do anything about it for 2 years. Once you've got a list of the databases that are running, figure out which ones hold sensitive information. You want to do a lot more about the database with your high-value client's personal information in it than you do with the database that's got the lunch menu for the office cafeteria. Next, you want to eliminate vulnerabilities. So you want to find the high-risk issues and fix them. The things you want to work on are making sure you've got secure configuration settings. So make sure your security controls are turned on and the database features you're not using are removed or disabled. You want to make sure you're using strong passwords. So change every single default password in the system. Scan your systems for any weak passwords you've got in place now and change them. And then do a good job enabling password complexity checking on your database so that you enforce some strong passwords going forward. Now that doesn't substitute ongoing password scanning, but it can really make it more difficult for somebody to put a really dumb password in place. Finally, apply security patches. So make sure your databases are patched up to date or within some time frame that you decide is acceptable for your business. Review those patch levels at least monthly. Database vendors are often coming out with patches, and you just need to stay on top of what you're exposed to so that you can make smart decisions about which patches need to be pushed forward and which ones you can wait on. Next, you want to enforce least privileges. So identify who your privileged users are, who has access to sensitive data, and manage segregation of duties. So you really need an automated process to do this so that you can figure out users' effective database privileges, not just the privileges that are granted directly to them. You want to do the best job you can cutting the privileges down that aren't required for each employee's job. Sometimes it's obvious and you can make a difference. You're never going to get it to perfect, but don't make perfect be the enemy of good. Control privileges that you grant to guest or public. So guest accounts, remove them if possible. If you can't possibly remove guest accounts from your database, make sure they don't have any privileges. Public is a built-in group in every database that gives privileges to all the users. It's very tough to manage because it tends to have thousands and thousands of default grants, and if you take them away, the database stops working. So look for non-default grants to public. Make sure you're not giving out any of those. And then usually every database vendor will publish a list of public grants that they gave by default that are kind of risky or very risky from a security perspective. Just make sure that you review that documentation and you revoke any of the rights on powerful or dangerous functionality that database vendors or security vendors for databases like AppSec are telling you about. And finally, check to make sure privileges are being assigned through roles, not directly granted to users. That's just the leading practice for managing privilege. Don't give privileges directly to your users. That becomes a management nightmare when you want to change somebody's privileges, somebody leaves or gets a new job. So that's what we can do proactively. The next step is to move on to our reactive approach. And the first thing we're going to do there is monitor for deviations. We've got our databases identified. We've got our vulnerabilities eliminated to the best of our ability. We've patched as much as we can, and we've cut as many privileges as we can, but we've probably still got vulnerabilities. We've certainly still got too many privileges. So now we want to monitor. We want to monitor who's accessing what data and when. We want to monitor for who's making what changes and when. So we want to audit all the privileged activity and access to sensitive data. And you really want to consider separation of duties. Don't put your database administrator in control of auditing your database administrator. That's like the ultimate fox watching the henhouse situation. You've got to make sure you've got separation of duties when it comes to your database administrators and who's auditing them, and even the system that's being used to audit them. If you're using built-in database auditing and the DBAs can just turn it off or delete the records, it's kind of useless. You want to also make sure that you reconcile any changes that you see with your audit logs with some approved changes and access rights, just to make, you have to make this auditing worthwhile. So make sure that the changes you see being made are actually approved changes, and you do that through reconciliation. The last step is to respond to suspicious activity. So if you see somebody accessing data they shouldn't be accessing by policy, or you see an attack against one of your databases happening, attempt to inject SQL or scripts or run an exploit, you need to be able to respond to that and really quickly get yourself on top of the incident response process. So suspicious activity hits the database. If you've got a good understanding for what that means and a security policy to react to it, you can do anything from just alert the IT team, automatically open trouble tickets. Maybe you want to put a blip up on the scope in your SIM, kick off a scanner like a malware scanner, or maybe even you want to take automated steps to prevent an attack by blocking the suspicious activity at the database. It's just important to have some kind of approach to incident response so that when something bad does happen, you're not reading about it in the paper tomorrow. You're reacting to it the minute that it happens. So we are just about out of time, and I am out of slides. I want to encourage you folks to come and visit teamshatter.com. That's our security research site. Shatter is the largest dedicated database security research team in the world. We find most of the vulnerabilities that the database vendors are fixing, and we write all about them and what you can do to protect yourself on teamshatter.com. So it's just a great website for you to visit. You can see my email address on the screen if you want to send me any questions. Now, I've got a couple of minutes here to take questions on the webinar, so I'm going to go ahead and open it up to questions. You can type questions right into the user interface here. The most common question that I get on all of my webinars is, will the slides be available? We're going to make some of the slides available to you folks. We're not going to ship you the exploit slides. Sorry about that. I'm also not going to send you the attack tools to do Oracle password guessing or help you attack databases in an automated way. We'll educate you, but we're not going to put those tools in your hands. If you've got any kind of questions, though, we'd be delighted to answer them for you. So questions are coming in. And a lot of them are, will the slides be available? So let me work my way through this. All right, so I've got a question from Lori. Would it be possible to address privilege and admin monitoring? Does it require that auditing be activated on the database? Also, what are the best practices for process ID creation, non-human ID creation, maintenance, and monitoring? So thanks for the questions, Lori. So it's pretty important, obviously, to monitor privileged administrators and understand what they're doing, because I think of the DBA as sort of the built-in segregation of duties violation on every database. They're the back office employee with full access to the business data. So you really do have to carefully track what they're doing and make sure that they're behaving and they're using the access that you've given them legitimately. But before you can effectively do that, you've got to know who your privileged users even are, which means having a good, solid understanding of the privileging that's occurred inside your databases. So you want to start by understanding who's got privileges and who is a privileged user. You want to revoke any privileges you can, and then for the users that really need to be DBAs or high level of privilege, you want to monitor what they're doing. Now you can do that with built-in database auditing, but you run the risk potentially of those privileged users bypassing the audit system. You might be better off using third-party software that can help you to do database activity monitoring in a robust way that an administrator can't. Now, when it comes to process IDs, there's a lot of things you can look at in terms of leading practice there. You want to clearly identify process IDs by name. There's typically two ways you want to treat them. You either want to ignore them. I don't want to audit any activity that runs by my non-human processes, or you want to examine them because it's actually an application connection that's serving on the behalf of a human user. You want to examine those activities as well and look for attacks that may have come through an application like a SQL injection or a cross-site scripting attack. And you want to run those through the database monitoring system as well, those connections, and look for attacks there. So you want to identify them very clearly so that it's easy to know you're looking at a non-human ID. And then, if these are used by anything beyond fully machine automated processes, anything that humans can get involved with, you probably want to watch what they're doing and look for any evidence of attack. All right. Let's look for some more questions here. So I've only got about 1 minute left. Herbert asked, how do our tools and techniques compare to Metasploit? So what we do at application security is primarily help people to find vulnerabilities and stop them from being exploited. Tools like Metasploit, folks can write modules to actually go through and run exploits and test systems to see if they're vulnerable. So it's nice kind of complementary world you've got out there. Not a lot of folks write database exploit modules for Metasploit, so you won't find too many of them out there, but there certainly are some. I've got a question on how we scan systems for weak passwords. The answer to that is to understand how the database vendors store password hashes, collect those password hashes, and then recalculate the passwords offline. And I've got a lot more questions, but I don't have any more time, so I'm going to wrap it up. We're going to take these questions. We're going to do our best to get back to you with some responses. If it would help us greatly if you didn't get your questions asked, just to shoot us a note. So you can send us a note at, you can send it to me directly. You can see my email address on the screen. Or you can send it to sales@appsecinc.com, and they'll make sure we get you some answers. We appreciate you joining us today. Thanks for your time, and look forward to this webinar being posted and made available online. At least if you want it, give us a shout, and we'll make it available to you. Because once again, I want to post all that exploit code available for everyone to see. Thanks again. Have a great day.